All right, welcome back. So, previous lecture we talked about the computer hardware system and then how different parts of the computer work together while executing a program. And now it is time for us to look at, in fact, how a C++ program looks like and what is the process of executing a program inside the computer, right? So then first look at then how we can, in fact, write a program. So that will be exciting, right? So in general then, so first of all, before we write a program, so we need to know how computer understand our program. So that's the language of the computer. So that's kind of similar to when you talk to somebody else as a human being. So we should speak in the language that that particular human being understand. So similarly, so computer understand a particular form of instructions. So that's called the language of the computer. So first we look at the language of the computer, and then we see the evolution of programming languages from what is called machine language to high-level languages. And then we look at our first C++ program. Okay, all right. So then first let's take a look at the language of the computer and then see exactly what are the different forms that computer in fact understand. Right now, if you look at a computer system, so in fact, so computer system is an electronic device. All right, so it has a monitor, CPU, and other stuff that we talked about earlier. Right now, this computer we can switch it on after plugging this thing into the power unit and then press the switch on button, right? So as the switch on button is pressed and then when you run the program, so what it does is then it takes power, that's the electric signals, and then these electric signals will be used to run our programs. So then what kind of electric signals that computer understand? So computer understand electric signals in this format, all right? So this particular format of instruction pretty much consists of low voltages like this and then high voltages like this. So a signal of this format is called a digital signal, right? So because it has two kind of forms, so low and high, right? So then here we have low and then here we have high voltages, right? Now then, so how we can represent these high voltages and low voltages in more encoded way? So easiest way for us to do that is to represent these low voltages using zeros and high voltages using ones. Okay. Now if I encode the first signal, so then we have 0 1, so 0 1, 0 1, and then 0. Now the second signal, so we have 0 here, and then so we have 1 1, okay, and then 2 zeros, okay, 1 1 0 1. All right. So then we have two type of instructions in here. So in the first one is 0 1 0 1 0 1 0. Second one is 0 1 1 0 0 1 1 0 1. Right. Now if I have my program written in this format, so then I can actually easily convert my program into digital signals like this nature, and those digital signals can be fed into the computer system to operate, right? So then essentially the way computer understand things is based on this format, right? So even with all of those evolutions, so still the computer understand this particular language. Now then what is the easiest way for us to write a program? So we can write a program using zeros and ones, correct? Right? So that one then is called the machine language. So then that's the language that machine, that's a computer, understand. Now I just want to show you how tedious task it will be to write a program using zeros and ones, right? So suppose I want to write a program that calculate the wage of a person by taking the hourly rate and multiplying that one by number of hours worked. So suppose this is what I want to calculate, right? So when I want to calculate this, then so I need to know how we can represent this instruction using zeros and ones. Now from the previous lecture we know that the first thing we need to do is we need to load the data values and then carry out the multiplication and then store the results back into wages. right? It's a fetch, decode, execute cycle that we need to do, right? So then in order for us to say load rates. So we need to give the instruction in 0, 1 format and then say load and where the data is coming from. Right? And then the second one is also the load. If you can see that it's the same bit pattern. Now the second data item is coming from this particular location, right? And then this is the instruction for multiplication. Okay? So multiply these two. Okay. So once you multiply this, so here we are saying store the results in this particular location, right? So that's the story. So therefore, in order for us to write a program using zeros and ones, so we need to know all of these encodings to represent all the instructions that we want to do in 0, 1 format. Right? So now if we represent these things in 0, 1 format, so what we can do is we can pretty much like put them into a paper format. So we call it like a punch card, and then punch holes to represent zeros, and if I don't have holes, that represent, let's say, 1. So then if I have a punch card like this nature, where we have holes and non-holes like this, so that's pretty much can represent a program like this nature in a card. So then we can feed these things into a card reader and then say go ahead and read my program and then give me the output. Now let's see why this is not a feasible thing to do. So one of the main issues in here is that suppose by mistake I put 0 here instead of 1. So the whole program will screw up and it's not going to pretty much produce the output that we want. So how do we figure that out? So we can figure that out after running the program. So we get the erroneous output, then we know that there's some problem in the encoding mechanism, right? So now how to figure out where the error is? So it's going to be really hard, because these zeros and ones, even if you miss a single bit in here, so our program is going to produce an erroneous result. All right. So therefore this is not going to be feasible for large scale programs. So believe it or not, however, so earlier people actually used punch cards to program in 1960s and 1950s, early 1960s. All right. So but then we know that that's not going to work with the more complex programs that we have here, with hundreds of thousands of instructions like this nature, right? Then for us to write a program, so if we can have a mechanism where we can have instructions written in this format where humans like us can understand, so that's much easier, right? So then rather than writing a program in machine language like this, so we would like to write a program in a high level programming language where instruction can be written in human understandable format like this nature, right? So that's led us to the evolution of different computer programming languages. So we call them high level programming languages. So their instructions are pretty much English like. So this is an example of a C++ instruction, by the way. Okay, so then we have so many different programming languages like BASIC, Fortran, COBOL, Pascal, C++. That's what we are learning in this class. And then another popular programming language is Java. Okay, so then we have these high level programming languages where we can write instruction in the form that we understand, right? So like this nature. However, still computers understand the machine language, the zeros and ones, right? So therefore this type of an instruction needs to be converted into zeros and ones before we run them, something like this nature, right? Now in order for us to do that, then so we use something called the compiler, right? So compiler will be used to take a program like this and then convert that one into 0 and 1 format, right? So let's take a quick look at it and then see what that process is before we go into a main program, right? Now in the compiler form, so this is what we have. So we have two forms. So we essentially have the high level program like this nature, where we call it actually the source code. All right, so the source code is in a high level program like this. Now this source code needs to be converted into what is called the binary code, right? So then doing this process, so we will require some sort of a software that takes our source code and then convert our source code into the binary code. All right. So now, what are the different things that the compiler do? So what the first thing compiler does is actually it checks whether we have written the program according to our the grammatical rules of the programming language. So every language has its own rules. So similarly, programming language like C++ also has its own grammar, right? So one example is every instruction needs to have a semicolon at the end, right? So then if you miss a semicolon, so that's a grammatical error. So then compiler can figure that out and then throw an error saying your program does not compile properly because it does not comply with the programming language grammar. All right, so that kind of error is called the syntax error, right? So then syntax error happens with the compilation to tell us the program is correct one or not. If the program is a correct program, it will generate the binary code. So then that binary code can be executed. All right. Okay. So now that we kind of understood what the process is, so then let's take a look at a C++ program now and then see how we can put an instruction like this nature into a C++ program. Right. Okay. So that's our first C++ program of the course, right? Okay, so congratulations. So we made it to this point. Okay, now in here then, so let's try to understand this program very carefully. So we said earlier that when you're writing a program, so we have to follow some grammatical rules of the programming language. All right. Now, according to the grammatical rules of the programming language, so every C++ program should start with something called a main method, right? So then main, and then the method symbol right here is representing starting from this place, so we'll have the main method, right? Now every method start with the curly bracket and then end with the closing curly bracket, right? And the next thing is that before we start running the program, so we'll usually tell the operating system and then say go ahead and run my program. So since we are telling the operating system to run my program, after running the program, so we should tell the operating system that we are done running the program. Now this return statement right here is telling the operating system that I have done executing the program, so you can give your memory to somebody else. So since 0 is a whole number, so we are returning the 0 from the main method. So we need to tell what type of a data that main method will be returning to the operating system to say that program has been executed successfully, right? So since 0 is an integer value, so it's a main kind of data item that we are returning from here. So we say that main method is going to return an integer, right? So int is referring to an integer. Okay, so therefore here the main template is something like this. So we have int main, okay, and then starting curly bracket and the ending curly bracket and then return 0. So that's kind of the template of writing a program. Now inside this, so we can write our own instructions needed for the program. All right. So now let's take a look at the instruction first, and then we'll look at this header parts after that. All right. Okay, so pretty good. So now inside this program, so we have program instructions, right? So we start with this cout instruction, right? Now this cout is representing an output device, right? So in the computer system, we said that we have input sources and output sources, right? So then here we have the monitor, and then let's say the input as the keyboard, right? So keyboard is connected to the computer. Now in programming world, so monitor is represented using the cout object, right? So keyboard is represented using the cin object. So then that's the direct representation of this computer hardware in the program. Now we are saying, so cout, that means send something to the monitor. So what do we send? So we send things in the right hand side of this particular operator. So this operator is called the read redirect operator, right? So this redirect operator is saying, so direct whatever we have in the right hand side of the operator into the output source mentioned here. So this program, the output source happen to be the monitor, right? Now what do we have as a data to send it to the monitor? So we have this data item first, right? So my first C++ program is a sentence. So in programming world, so sentence is called a string, right? Now if I am sending a string into the monitor, so we need to represent those strings using double quotes, right? So that essentially is saying send my first C++ program sentence into the monitor. So if you were to run the program, so then we will see actually my first C++ program in the first line, right? Now after displaying it, so we have another redirect operator and then end L. So end L stand for end of line, right? So that means that we display what we have and then go to the next line. So therefore after displaying my first C++ program, so we will be going into the second line. Now in the second line, so we have another cout statement. So that means we need to send whatever in the right hand side of the redirect operator to the monitor again. So in here we are saying sum of 2 and 3 equals. So now we know that this whole thing is a string again, okay? And then so we have another data item separated by the redirect, okay? So this data item is a number. So since it is a number, we don't need to have double quotes, right? So the numbers can be placed without double quotes. So this one is saying, so first send this string into the monitor and then send number 5 into the monitor, okay? So then the second statement will be, so sum of 2 and 3 equals 5. Okay. Now after doing that, so we move on to the next line, all right? So then this end L is basically saying go to the next line, right? Now in the next line, so we have quite interesting stuff. So we have a string to begin with, so 7 plus 8 equals. So since 7 plus 8 equals is inside the double quotes, so this is considered as a string. So therefore this arithmetic operation will not be performed. So then we'll be pretty much displaying this whole thing as it is. Now after that, however, after this redirect, so we have 7 plus 8. Now this 7 plus 8 is not within double quotes. Since it is not within double quotes, so this will be an arithmetic addition. So then we will first add these two numbers and then send the results into the cout, right? So because of that, so we'll get 15. So that's the arithmetic addition we are doing in here, all right? So the important thing is then, so when you have numbers like this nature, like 5, 7, 8 and so on and so forth, so inside the redirect we can perform arithmetic operations as well, all right? So addition, subtraction, multiplication, division and so on and so forth, okay? Then so far in this program, so what you did was, so we had 3 different cout statements. So each of these cout statement will be sending some data items to the monitor. So first one is a direct string, second one is a string plus some data value, that's the number, and third one is a string plus some data value with an operation, so addition operation, right? So then that kind of covers the basic set of operations we can do with the cout. So we'll expand on this one. So I hope we got a good idea about so how we can send some data item to the monitor using the cout object and the redirect operator, specifically strings and integers and other numbers, all right? So with that note then, so let's take a look at what we have before the main. Now before main, so we have 2 different type of instructions in here. So first one is saying include IO stream, right? So now this one is something to do with the meaning of the instruction, right? So suppose you start reading a book and then you can come across a new word that you had never seen before, and you want to know what is the meaning of it. So what you do is, so we can go to the library and then take the dictionary and then see what the meaning of the word is. So likewise, when you're writing programs, so we are putting a lot of instructions like cout, so redirect, endl, and so on and so forth. Now, during the compilation process, so compiler needs to know so where these things have been defined and what is the meaning of these things, so it can then generate the appropriate machine code, right? So then those instructions are defined in the libraries. So C++ has collection of libraries, all right? So then this IOStream library is representing input output stream library, right? So here we are using cout, then cout is defined in this library, right? So when we are saying include this library in the program, so this special symbol is the one that we use to include a different part of the library, C++ library, in a program, all right? Then we need to say that where this library is defined in C++, so the place that these standard things are defined is called the namespace std. STD stands for standard namespace. So it's pretty much like when you go to a library, so we see different maybe buildings and also different sections where we have maybe math books, science books, and maybe novels that we read and that kind of stuff, right? So then we categorize depending on the type of books, all right? So likewise, in here, C++ library has different categories. Now, standard library is the one that define all the standard definitions, all right? So we call it namespace std. Then we are saying using namespace std. So that essentially says go to the standard library and then use the standard definitions in this namespace to get the meaning of these instructions in the program, all right? So therefore, this is called the input output stream library, where output and input related operations are defined, all right? Okay, so I hope we got a good idea about then how the program looks like and what happens when you are putting a program together. And with that note, so we can take a look at another quick checkpointing question and see if we understand the basic syntax of a program. Okay. All right. So now let's take a closer look at then what happens. So as we compile a program. Okay. So now that we have looked at how the program structure looks like, and then what are the different set of instructions in the program. So the next process we talked about is a compilation process, where we take a compiler and then take the code and then convert the code into the machine language code, right? So then in the compilation process, so there are few steps that we have. So initially, so we have the source code, all right? Then source code is a program that you guys have seen earlier. Okay, so then we take the source code, so right here. And then after checking the source code, so the next thing we look at is to see whether it's grammatically correct, right? So then we compile it, right? So when you compile it, so we check for grammar rules. So that's called the syntax of the program, right? So this is instruction like cout, hello, and then endl, all right? So in this instruction, for example, if we compile it, so this one semicolon is missing, so then it's going to throw a compilation error or the syntax error as compilation process go through, all right? So then we can fix it by adding a semicolon, and then it compiles correctly. Now after compiling it correctly, so next thing we need to do is actually, so we need to link with appropriate hardware related code that allows us to execute the code in the computer hardware, right? So that process is called the linking, right? So that links to the hardware related dependencies, right? That means that if we link it and run it in maybe a Windows machine versus Unix machine, so this linking process can be different for some instructions, but in general, so most of these basic instructions will have the same kind of linking process. All right, so then we take the source code, compile it, and then figure out whether it has a syntax errors or not. If it does not have any syntax error, so then we link it and then create the executable code. So that will produce us something like this in the 0 1 0 0 or let's say 1 format. All right, and that can be executed in the computer hardware. Now this one is called the binary code, right? So then binary code can be executed, right? So that's kind of the compilation process. Okay, so we take the source code, so compile it, link it, and then it produces a binary code. So that's the executable code, so that can be executed in a computer hardware like this. Okay, now in order for us to follow this process, so we need to have something that help us in doing this process. All right, because we need to have a way to type the program and then save it and then compile it and then link it and then produce the executable code. Right, now in order for us to do that, so we have what is called editors or IDEs. So IDE stand for Integrated Developer Environment. All right, so we can use that environment to type the program, so compile it and then produce the executable code. All right, so then the main idea behind this IDE is to have the editor portion and the compiler portion that allows us to edit and compile and then link the program, so then we can run it. All right, so in general for C++, we have so many different IDEs that we can use, but in this class we will be using Visual Studio for Windows computers, and then we can use Xcode if you are a Mac user. All right, so Visual Studio then can be used in typing, compiling, and then producing the executable code in Windows environment. So likewise Xcode can be used in typing, compiling, and developing the executable code for C++ program. All right, so these things are called IDEs or integrated development environments. All right, now in the together with the lecture note, so we have posted two tutorials. So one is to show how we can use Visual Studio to type, compile, and execute a C++ program, right? And also there's another video so that demonstrate how to use Xcode in developing a C++ program for Mac users, right? So then we strongly encourage you all to take a look at those two videos and then get familiar with the Visual Studio or the Xcode depending on which one you're using, and then make sure that everybody can type, compile, and run a program, right? So after doing that process, so we can get started with lab number 1 and then complete it. So that's kind of getting used to the developer environment like Visual Studio or Xcode, and then getting familiar with the process of compiling a program. Okay.